This was a problem from your previous homework where you had to find the integral of these of this function f of x according to the limits that we're looking at. So I'm going to start off with this example. I'm just going to do part A really quickly. So part A, for this we look for the area between 0 and 2, and we look at the area underneath the curve with respect to the x-axis. Okay, so we'll say that shape is probably a trapezoid, so we take 1/2 of the bases, so that's 1 plus 3 times the height, which is 2, so that gives us an area of 4. So the integral from 0 to 2 of f of x is 4. Okay, that's great and all, but the thing is, not all of our functions that we're going to be integrating are going to be nice shapes like this. Like for example, if we had asked what is the area underneath the sine curve from 0 to pi, it's not easy to find the area using some geometric interpretation, right? So what we're going to use then is something called the fundamental theorem of calculus part 1. So FTC1. FTC1 states this, that if you want to interpret this, it's the same thing as taking the antiderivative. So quick notation, if this is the derivative, then the antiderivative is this. So that means I take the antiderivative of the function, so in this case the little f of x, the antiderivative will be big F of x, and then we evaluate it from 0 to 2. And then what we do is we take the difference of when we evaluate these two limits, and this is actually going to turn out to be the area. So okay, I'm going to restrict this problem just to be this line. So there's no other part of this graph, okay? Let's imagine this is our f of x is this nice line, which gives us the equation x plus 1. So once again, we're integrating f of x from 0 to 2 dx, and that means the function, I'm going to replace that with the x plus 1 dx. Now let's take the antiderivative of this with respect to x, so that gives us x squared over 2 plus 1, and now we're going to evaluate it from 0 to 2. Okay, so I'm running out a little space, I'm going to continue over here. So now we evaluate the, what did I forget? I forgot the plus c. And you'll see in a second that that plus c won't matter anymore. But check this out. Okay, so we evaluate the 2 and the 0 into this function now. So you notice how I evaluated 2 first and then evaluate 0. So it's always the upper and then the lower. And then we take the difference of the two numbers. It's always a difference. It's always going to be the difference. And now let's just simplify. Oh, but I made a mistake. Oops. This should have been plus x, I think. Yeah, it should have been plus x because the antiderivative one is x. So let me fix that here and here. So we evaluate 0 and 2. Okay. Okay, now let's see what happens. So simplifying this, I notice we have this c minus c, so those actually cancel out. This turns out to be, 4 over 2, so this is 2 plus 2, so that gives us 4, and this is minus 0. So it turns out this integral is equal to 4. So in other words, instead of having to find the area underneath the curve using geometric methods, what we're going to do is use the fundamental theorem of calculus, which states we find the antiderivative, evaluate the upper and lower limits, take the difference, and that will give us our solution. And once again, did you notice that this plus c at the end didn't even matter? And the reason why it did not matter anymore is that we were not taking the general antiderivative. We're given specific values to plug in. So when I was doing this right now, when I was taking the antiderivative, in my head I was already thinking, oh, I don't need that plus c because I know I'm evaluating limits. So from now on, whenever you see limits that we're integrating from, do not include this plus c because it's kind of just extra stuff that we do not need. Okay, so let's take a look at example 1 from 6.3. So we evaluate this thing. I don't know what the graph of this function looks like, and I don't care, because now we're going to use FTC1. So FTC1 says that we're taking the antiderivative of each part. So antiderivative of e to the x, well, that's itself. The antiderivative of minus 3 is going to be minus 3x. And now we're going to evaluate it from 1 to 3. So another thing, this is just notation. We write this vertical bar at the end to say that we're evaluating from these values. So now we just evaluate 3 and 1, and we're going to take the difference. And then let's not forget, it's always going to be the upper limit minus the lower limit. So now this gives us this, which we can't really simplify without a calculator, so we're just going to leave it as e to the third minus e minus 6. Now for example B, we have this. Now just like when we take the derivative of functions, with constants, you know how we like kind of just ignore that for a second? Well, I'm going to do that too. I'm going to actually throw that out to the front, so now this is 2 times the integral. Which then I notice from our chart on the previous page, this is actually the antiderivative of this is